Hi students, this is Ms. Johnson with 3-3 rate of change and slope. Our SWABAT for today is we are going to be finding slope and the rate of change, and we're going to be using them to solve problems. Alright, let's first of all define what these things are. Rate of change. Rate of change is our change in y's divided by our change in x's. And the way that we find our change in y's is we actually subtract two y values. So we'll take a y value subtracted by another y value, and we just call it y2 minus y1. And we take two x values and subtract them, and then we divide them, and that will give us our rate of change. Slope actually also means the rate of change, and rate of change also means slope. Two different words that mean the same thing. Slope, as we've talked about before, slope is the m value in our equation y equals mx plus b, so it's that number that's in front of x. Slope also tells us the steepness of a line, the steepness going up or the steepness going down. And we can find the slope by doing rise over run, our change in y's over our change in x's, just like we did for our rate of change. So y2 minus y1 divided by x2 minus x1. And I tend to try to remember these as that rise and my y's go together, and run and my x's going across. You run across just like an x, you go across when you make it. Rise and y's. Alright, what does slope look like? Well, there are four different kinds of graphs that we have seen. If it has a positive slope, as you read it from left to right, just like a book, the line will be going up. If a slope is 0, the line will go straight across, and I think about this kind of like skiing. If you're cross-country skiing, you're going to go across on a slope of 0. A negative slope, as you read it from left to right, is going down, and that would be like downhill skiing. And a slope can be undefined if that line goes straight up and down. So if you're skiing and you come to the edge of a cliff, you look over and you say, there is no way I am skiing down that. That is undefined. Alright, let's get to our first problem. Example number 1, find the rate of change in this table. We've got the number of computer games is going to be our x, and the total cost for purchasing them is going to be our y. So to find our rate of change, we're going to find our change in our y's divided by our change in our x's. So I'm just going to pick any 2 points out of this table. I'm going to pick 4 and 156 as one of my points, and I'm going to write that as a coordinate pair of 4, 156, and I'll pick this second point of 6 and 234. Again, I'll write it as a coordinate pair of 6 and 234. We know that the first number is x, our second number is y, but because this is our first point, I'll just call these x1 and y1. And our second point, we'll call those x2 and y2. But as I said, you can choose any of these points. Then what we're going to do is we're going to set them up and find our rate of change. So we're going to take our y2, which is 234, and we're going to subtract our y1, which is 156. 234 minus 156 is 78. Down in our denominator, we are going to subtract our x values. So x2 is 6, x1 is 4. So I'll subtract my 6 minus 4 and get 2. So my change in y's is 78, my change in x's is 2. I divide those and we get 39. So that means our rate of change is 39. So in this problem, it costs $39 per computer game. So the rate of change is how much it costs for one thing, for one game. Alright, moving on to example 2. We need to determine whether each function, or each table here, is linear. Well, in order for things to be linear, the rate of change, or their slope, must be constant for everything. Meaning all the y's have to have a constant rate of change, and all the x's have to have a constant rate of change. So again, we're going to set it up just like we did with example 1. We're going to pick any 2 points, and I'll just take the first 2. So I'll take 1 and negative 6 as my first point, and I'll take 4 and negative 8 as my second point. Okay, just to write them as a coordinate pair, we've got 1 and negative 6, we've got 4 and negative 8. So I'll label them x1, y1, x2, y2. So to find my rate of change, I'm going to subtract my y values. So I'm going to have negative 8 minus negative 6. Then I'm going to subtract my x values, 4 minus 1. Alright, so ahead of it setting up, finding the change in y is negative 8 minus negative 6. Well, remember, when we subtract a negative, it's really like adding a positive. So we've got negative 8 plus 6. Negative 8 plus 6 is negative 2. Difference in our x's, 4 minus 1 is 3. So what this means is our rate of change is negative 2/3, which means our y's need to go constantly down by 2, because it's negative 2, so they're going down, and our x's need to go up by 3. So when we take a look at our table, our y's need to go down by 2. Well, let's see, negative 6 down 2 gives us negative 8. Negative 8 down 2 gives us negative 10. Negative 10 down 2 gives us negative 12. And negative 12 down 2 gives us negative 4. Checking our x's, going up by 3. Yes, 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. And 10 plus 3 is 13. So, yes, this table is linear. Alright, let's try the second table. Alright, again, we're going to find our rate of change, so we're going to pick any 2 points. And again, I'll just pick the first 2. So we've got negative 3 and 10, and negative 1 and 12. Why don't you see if you can pause the video and set this up? Alright, so you should have set it up with your change in y's being 12 minus 10, and our change in x's of being negative 1 minus negative 3. Don't forget about those negatives. Alright, so to subtract it, 12 minus 10 is obviously 2. Negative 1 minus negative 3, remember subtracting a negative is adding a positive. So negative 1 plus 3 gives us 2. So our rate of change is going to be 2 over 2. So our y's need to go up by 2, and our x's need to go up by 2. Alright, checking our x's, negative 3 plus 2 is negative 1. Negative 1 plus 2 is 1. 1 plus 2 is 3. 3 plus 2 is 5. Works out great. Okay, when we go to the y's, 10 plus 2 is 12. 12 plus 2 is not 16. Okay, because this does not go up by 2. It doesn't have that constant rate of change. This table is not linear. It doesn't work for everything in the table. Again, to be linear, the rate of change must be constant for all your points. Alright, let's move on to slope. Okay, again, slope is just like the rate of change, so we're going to find the slope through these pairs of points. Example A, we've got negative 2, 0, and 1, 5. Want you stop the video, pause it, and see if you can get it all set up. Finding the change in y's over the change in x's. Our rise over our run. Alright, rise over run. Rise is our y, so 5 minus 0, that gives us 5. Subtracting our x's, 1 minus negative 2. Subtracting a negative means adding, so 1 plus 2 is 3. And then we want to go one more step, is we want to divide 5 divided by 3, which is about 1.6. So the slope between these 2 points on a graph would be a positive 1.6. It'd be going something like that. Ooh, bad graph. There we go, this one looks a little bit better. The slope of this line will be looking something like this to connect these 2 dots. Alright, example 3b, 4, 3, and negative 1, 11. Again, pause the video and get this set up, finding your slope. Alright, let's check and see if you got it right. Change in our y's, our rise, you're going to use 11 and 3. 11 minus 3 is 8. Finding our run is our x's. We are running from negative 1 to 4, so negative 1 minus 4 gives us negative 5. When we divide, 8 divided by negative 5, we get negative 1.6. So we get the same answer, except this one is negative. So that means the line to connect these 2 points would be going down. It would be a slope looking something like this. All right, one last example. Find the slope that passes through these 2 points, -2, 4, and -2, -3. Again, pause the video, see if you can set this one up. Get it right. All right, finding our rise is our y's. Working right here. -3 minus 4 gives us -7. We're working with our run is -2 minus -2. Again, subtracting a negative really means adding a positive. So -2 plus 2 is 0. So now we need to divide. -7 divided by 0. Well, you can't do that. If you punch it in on your calculator, it will give you an error. You cannot divide anything by 0. So because we can't divide by 0, our slope is undefined. This is a graph that's going straight up and down, not something that you'd want to ski over, so it's undefined. All right, that is finding rate of change and slope. Thanks for listening. Do a good job with your problems.